Right, so in this video I'm going to have a look at even and odd functions. So let's just start with even functions. Now the definition of an even function is where f of x is just going to be equal to f of minus x, or the negative of x. So your basic even function would be f of x is equal to x squared, and you know that will look something like this. So if I draw the x-axis and the y-axis here, you know the graph will look something like this. It'll be basically symmetrical around the y-axis. Okay, so you can see here that, for example, let's take this x value here, let's take it as being, I don't know, let's say 3. So you can see here that if you put 3 into our function here, you'll get 9 out. Also, if you take minus 3 here, put that into your function, you'll also get 9. So in other words, if you put 3 into your function, that's going to be 3 squared, which is 9. Also, if you put in minus 3 into your function, that's going to be minus 3 squared, which is also 9. So f of x, f of minus 3, is equal to f of 3. So therefore this function here is even. There are other even functions as well, so you can take, for example, if I draw another x and y axis, you can take, let's say, this function here, which is just f of x is equal to the modulus of x. So any x value here, let's say 5, the modulus of 5 is just going to be 5. If you take negative 5, minus 5, the modulus of minus 5 is also going to be 5. So you can see something similar between these two graphs. You can see that basically the right hand side, the part of the graph in the first quadrant here, can be reflected through axial symmetry in the y-axis to give us this part of the graph here in the second quadrant, and it's the same here. So this part here of the graph is just a reflection of this part here of the graph in the y-axis. Now I've drawn a more kind of complicated one here. Let me just see if I can bring this up. This is what it looks like here, and this is y is equal to x cubed times the sine of x, and this is what it actually looks like. And it mightn't be obvious from the actual function itself that this is even if you weren't given the graph, but you can see that it is symmetrical around the y-axis. So if you take 2, for example, come up here and go across, you get something up here around 7.5, I think. If you take minus 2, you'll get the same value. So the f of 2 is equal to the f of minus 2 here. Now, how do we actually go about checking that? Well, let me just write it out and we'll just work our way through it algebraically. So our function is here is f of x is equal to x cubed sine x. So as I say, looking at that initially, you wouldn't think that it was, or you can't see immediately anyway that it's an even function. So what do you do? Well, this is our f of x. Let's put in minus x into this. Well, that will give us minus x cubed, and then the sine of minus x here. So this just becomes, well, minus x cubed is going to be, well, if you cube negative, you're just going to get a minus. Cube x, you get x cubed. Now the sine of minus x, the sine of minus x, the sine of a negative angle, is just going to be minus the sine of the positive angle, because the sine of, for example, if this is our x and y axis, minus x will be down here, so this is our x, our angle x here, and sine is negative in the fourth quadrant, so therefore this is our reference angle here, so this would be x in the first quadrant. So really the sine of this x here is the same as the sine of this x here in the fourth quadrant, however it will be negative. So in other words, this is just minus the sine of x. So that just gives me in total, then I have a minus times a minus here, so that's x cubed sine x. So look what I've done here. I've put in x into my function and I've got x cubed sine x. I put minus x into this function as well, and I've also got x cubed sine x. Therefore this function here is even, because we can say then therefore f of x is equal to f of minus x. We get the same y value. This is f of x and this is f of minus x, and they're exactly the same. Therefore this function here is even, and we saw that from the graph that I showed you earlier. Okay, so let's have a look at an odd function, or some odd functions. Well, odd functions, just write this down, let's just do this in white. So odd functions. Okay, so odd functions then, they have the definition that f of x is equal to minus f of minus x. So let's have a look at what that might look like. Well, if we take our x and y axis again, and let's take a basic function, y is equal to x cubed. So it will look something like this. It'll come down along here, across here, and down along here like this. So this is f of x is equal to x cubed. So in this particular case you can see that it's not even, because if you reflect this part of the graph here in the y-axis, you don't get this kind of thing up here. However, if you reflect this part here in the x-axis, you will get this part down here. So in other words, you're doing two reflections here. You're reflecting this part of the graph in the y-axis first, and then reflecting that reflection in the x-axis, and you do end up with, you know, back on the graph again. You can also reflect this in the x-axis and then across in the y-axis, but let's just reflect in the y-axis first and then the x-axis for in this video anyway. So in other words here, let's take 2 here for example, and we'll take minus 2. So if we put 2 into our function, we get f of 2. So that's going to be up along here and over here. Well, that's just going to give us 8. If I put minus 2 in here, I'm going to end up down here somewhere, and that's going to be minus 8. So if I actually do that, f of 2 is equal to 8. F of minus 2 is equal to minus 8. So if you look at our basic definition here, this definition here of an odd function, f of x is equal to minus f of minus x. So f of x here, f of 2 is equal to 8, and f of minus 2 is equal to minus, or f of x, minus 8 in other words. So this is an odd function. So in this particular case, f of 2 is equal to minus f of minus 2. F of minus 2, in other words, this part here of our function, this part here, f of minus 2 is minus 8. So that's just minus 8. So here we end up with minus 8. On this side we have 8. So minus 8 is 8. And here we have 8 on this side. So f of 2 is equal to minus f of minus 2. So therefore this function here is odd. Now another example would be maybe something like this. If we take our x and y axis again, and we take a, let's take a line like this. This is just the line y is equal to x. So again, you can see if you reflect this part of the graph in the y-axis, you'll get something like this, and if you reflect this in the x-axis, it'll end up down here. So again, if we take a value here, let's take 4 and minus 4. So f of 4 is just going to be equal to 4, because remember y is equal to x. F of minus 4 is going to be equal to minus 4. So f of 4 is equal to 4. F of minus 4 is equal to minus 4. So f of 4 is equal to minus f of minus 4. So this means it's an odd function. F of x is equal to minus f of minus x. Okay, so that's really your definition of an odd function, but you can also have functions that are neither even or odd. So I've taken an example here. I'll just show you on this GeoGebra file here. Let me just get rid of this, and we'll put in this one. And this is this one here. It's x squared plus x. It's a quadratic, however it's moved. We did y is equal to x squared earlier, so that's symmetrical around the y-axis. Now in this case, this is y is equal to x squared, however it's moved over to the left and it's moved down a bit as well. So you can see it's not symmetrical around the y-axis. So in this particular case, you can see here that if you take 2, put that into your function, you'll get 6. 2 squared is 4, plus 2 is 6. If you take minus 2, put that into your function, you'll get 2. So f of 2 is not equal to f of minus 2, so it's not an even function. You can also see it's not odd. If you take this part of the function here, reflected in the y-axis, you will get, something up around here. If you reflect that in the x-axis, it'll actually be down here somewhere. So f of x is not going to be equal to minus f of minus x. So this is neither even nor odd. Okay, so that's really your definition of even, odd, and neither even nor odd. I mean, another one that wouldn't be either even nor odd would be this one here. Again, if I just draw an x and y axis, and let's say we have a function that looks something like this. So this would be y is equal to, say, e to the power of x, this exponential function here. So again, I mean, it's fairly obvious by looking at it, but if you take 2, put it in here, you get this value up here, e to the power of 2. If you take minus 2 and you put that into your function, you don't get the same value, so it's not even. Also, you can see it's not odd, because if you reflect this part here in the y-axis, you get this kind of thing up along here. If you reflect that in the x-axis, you get something down here like this. So clearly this is not part of the graph, so it's neither even nor odd.